Hello, welcome to my video series of algorithms. This is part 9 of Module 2, Logic and Proof. In this video, we will discuss some common proof errors. In the previous video, we have learned several proof techniques. Those proof techniques correspond to some commonly used valid argument forms. On the other hand, some invalid argument forms are also commonly used, and they correspond to the common proof errors that we will discuss today. Specifically, we list the proof errors to discuss here. First, we have the converse error. It means the proof uses the incorrect argument form of P implies Q, Q, then P. For example, one may say, if you have attended every class, you will receive an A for this course. You receive an A, so you must have attended every class. The conclusion, you must have attended every class, is wrong. The conditional statement, if you have attended every class, you will receive an A, does not rule out the possibility that some students can receive an A without attending every class. You can also see why the argument form is invalid from the truth table. There exists a case where all premises are true, but the conclusion is false. The second error is the inverse error. It means that the proof uses the incorrect argument form of P implies Q, not P, then not Q. For example, one may say, if you have attended every class, you will receive an A for this course. Because you didn't attend every class, so you will not receive an A. For a similar reason, the conditional statement does not rule out the possibility that some students can still get an A without attending every class. Therefore, the conclusion that you cannot get an A is incorrect. You can also see the logical error of the argument form from the truth table, where you can find a case where all premises are true, but the conclusion is false. Third, we could reach a false conclusion even if we use a valid argument form. For example, consider the following proof. If cows can fly, I will be rich. Cows can fly, so I'm rich. The argument form used by this proof is modus ponens, which is valid. However, the second premise, cows can fly, is false. Therefore, the conclusion, I am rich, is also false. Recall that to construct a sound proof, we need to satisfy two conditions. First, all premises must be true. Second, the argument form is valid. In this error, although the second condition is met, the first one is not. Fourth, we could also reach a true conclusion using an invalid argument form. Consider the following proof. If New York is a big city, it has many tall buildings. New York has many tall buildings, so it is a big city. The argument form used here is P implies Q, Q, then P, which is a converse error we just discussed. However, the conclusion that New York is a big city is a true statement. From this example, we know that sometimes we can reach a correct conclusion without using a correct logic. However, even if the conclusion is valid, the proof itself remains invalid. Next, we have an error called arguing from example. For example, show that the sum of two even integers is an even integer. One may prove the statement by making an example where the two even integers take values of 2 and 6, and showing that their sum 8 is also an even integer. The proof is incorrect as it does not discuss other values in the domain that the variables can take. Note that proof by example is only valid when trying to prove an essential statement. It is invalid when used to prove a universal statement. To prove the statement we have here, we should use the generalization of a generic particular. Then, some incorrect proofs involve the use of ambiguous premises. For example, one may say, women love shopping, Jane is a woman, so Jane loves shopping. The argument form used here is universal instantiation, which is correct. However, the premise, women love shopping, is ambiguous, as there are many different ways to interpret it. It could mean some women love shopping, which is correct. Or it could mean all women love shopping, which is incorrect. Depending on different interpretations, the premise that women love shopping can be either true or false. Recall that to construct a sound proof, all premises must be true, and none can be ambiguous or false. In this case, the proof we have here is incorrect. The next error is made when we use the same notation to mean different things. For example, show that the sum of two even integers is an even integer. The proof selects two generic particulars, m and n. Because they are both even numbers, they can be represented as 2 times some integer k. It then represents m as 2k and n as 2k as well. It subsequently shows that the sum of m and n is an even integer. The issue of this proof is that it used 2k to represent both m and n. In this case, it implies that m and n are two identical even numbers. With this constraint, the two particulars m and n are not generic anymore. What this proof has actually shown is that the sum of two identical even integers is an even integer, which is different from the statement we want to prove. The eighth error is jumping into the conclusion. When constructing a proof, the premises and the argument form must be logically connected. In this case, the reader can follow the train of thought and reach the conclusion. Note that something is clear to you does not necessarily mean it is also clear to your audience. If you skip some details of the proof by assuming it is easy and simple, you may leave a lot of confusion to your audience. For example, Fermat once came up with a theorem, which says that no three positive integers a, b, and c can satisfy the equation a to the power of n plus b to the power of n equals c to the power of n for any integer value of n greater than 2. This is also known as Fermat's last theorem. Fermat first stated the theorem around 400 years ago in the margin of a copy of Arithmetica. He added that he had a proof, but could be too long to fit in the margin. I imagine the proof could be easy for him, as he seemed to have considered fitting it in the margin. Unfortunately, the proof was not easy and obvious for us at all. After 350 years of effort, the theorem was finally proved by Andrew Wiles in 1994. Fermat could have included his proof and saved the math community 350 years of time. The ninth error is begging the question, or circular reasoning. The error happens when you assume what needs to be proven. Let's consider the conversation between a customer and a stockbroker. The customer asked whether buying the stock could make money. The broker suggested that the customer buy now at a low price and sell in the future at a higher price. In this case, the customer will be able to make some money. If you think twice, the broker has assumed that the stock price will rise in the future. The assumption that the stock price goes up in the future is the same as assuming making money from buying the stock. despite that they are not expressed in the same way. Now, while the broker needs to prove buying the stock can make money, it assumes that stock price will rise, which is logically equivalent to what needs to be proven. In this case, the broker assumed something that has not been proven, which could be a false or ambiguous premise. As a result, the corresponding proof is invalid. At last, we have an error called misuse of the word if. The error happens when we use the word if to mean something true and should be considered as a premise. Note that the word if is used to mean the condition of a conditional statement. It simply says that when the condition is true, then the conclusion is true. It does not necessarily mean that the condition is true. For example, when we say, if Tom is hungry, Tom will eat, we cannot conclude that Tom is necessarily hungry. So, Tom is hungry cannot be considered as a premise because it may not be true. On the other hand, if we want to use Tom is hungry as a premise, we should not state it under the word if. Also, consider the example given here. Suppose P is a prime. If P is a prime, it cannot be written as the product of two smaller positive integers. Since the first sentence, suppose P is a prime, has already declared that P is a prime as a fact, we should not put the statement after the word if in the next sentence, because it implies that P is a prime may not be true. We should say because P is a prime instead. In summary, we have discussed several common errors found in proofs. This is the last video of this module. Thank you for watching and see you next time.